These are video notes on how to subtract integers. We're going to be looking a lot at what we did with adding integers and seeing how we can use that to carry over to subtracting. As always, be sure you're copying all the problems, the work, and writing down what the solution is. Be sure the sound is on and that you can hear what's happening. All right, just like before, we're going to look at two different methods. One is going to use the integer counters, and one is going to still use our number line. With our integer counters, instead of just adding everything together now, since it's subtraction, we're actually going to be taking away. So as an example of what that looks like, if we were to do, let's just do something simple, 5 minus 3, I would start with whatever my first number is. So positive 5, and then instead of adding in this second number, I'm just going to take away 3 of those. So once I take away 3 of those, I'm left with positive 2. And so we're going to look at how that works when we start including some negatives. We're also going to be using our number line with integer man, and this time we're going to add into the rules that we already know. So we had our addition rules. Adding a positive goes right, adding a negative moves left. Since we're subtracting, it's basically the opposite of what our addition is. So this time if we subtract a positive, he's going to move left. If we subtract a negative, then he's going to move to the right. So subtracting a negative basically means he does not go left, and that means he has to go to the right. Okay, let's look at some examples. So our first example is negative 2 minus 4. And I'm going to show that with the chips. So just like before, we'll start by showing our first number. So now we have negative 2, and it says take away 4 positives. But since I don't have 4 positives to take away, this is where I can use my 0 pairs until I get 4 positives. So what I'm going to do is I'm going to add 0 4 times. So here's what that looks like. Okay. Add 0, that's my 0 pair. That value of all the chips still equals negative 2. I haven't changed the value yet. I'm just making it so that there's some positives. And then I'm actually going to do that 4 times. So 4 sets of 0. Again, all of this still equals negative 2 because these right here all 0 pairs. I'm not actually adding or changing the value. It still equals negative 2. What I can do, though, is now I can take away these 4, because this says start with negative 2 and then take away 4 positives. So now when I take away those 4 positives, those are not included, I'm going to be left with 6 negatives. So negative 2 minus 4 is going to equal negative 6. Okay, let's look at what that looks like in case you like the number line a little bit more. We're going to start at negative 2, so integer man's going to start right here, and we're going to take away 4. So just like you're used to, subtract 4, the number's going to get smaller, so integer man's going to move to the left 4 spaces, 1, 2, 3, 4, and he's also going to end up at negative 6. Okay, next example, we're going to do 5 minus negative 2. So we'll start with our chips, 5 positives. Will look just like this. Okay, and then it says start with 5 and take away 2 negatives. But kind of like before, I don't have that to take away. There are no negatives there. So this is where I'm going to add in 2 0 pairs. So there's 1 0 pair, and there's 2 0 pairs. All of those integer chips still equal 5 when you cancel out the 0 pairs. But now I can take away 2 negatives. So when those are taken away, 5 minus negative 2 is actually going to be positive 7. So that's kind of a weird example where you take something away and you actually end up with a larger number. Let's look at it on the number line. Integer man's going to start over here at positive 5, and we're going to take away 2 negatives. So basically he is not going to the left, which means he has to go to the right 2 steps. So he's going to go to the right 2 steps, and you can compare that back to what our rule was right here, where when we subtract a negative, integer man's going to move to the right. Okay, so both ways we end up with positive 7. All right, next example, negative 3 minus 7. So using chips, start with 3 negatives, and then it says take away 7 positives. So there's no positives right now. We're going to add in 7 zero pairs. So there's 1, there's 2, there's 3. Actually, slide this over just a little bit so we've got room. Okay, so 3 zero pairs. There's 6 zero pairs, and then our last one. So we added in 7 zero pairs, and now I can take away 7 positives. So 1, 2, 3, 4, 5, 6, 7. All of those get taken away, and now I'm just going to count up all my negatives. So I've got 3 here, 4, 5, 6, 7, 8, 9, 10. So final answer is going to be negative 10. Okay, integer man, he's going to start at negative 3, and since we're subtracting positive 7, he's going to go to the left 7 steps and end up at negative 10. So negative 3, 1, 2, 3, 4, 5, 6, 7, and he also gets negative 10. Okay, next, negative 8 minus 5. So we'll start with 8 negatives. And we're going to take away 5, or take away 5 positives. So this is where we're going to do 5 zero pairs. There's 1, 2, 3. Move this over again. And 4, 5. So there's my zero pairs. And I'm going to take away 5 positives. So 1, 2, 3, 4, 5. And then we're left with the negative 8 we started with, negative 9, negative 10, negative 11, negative 12, negative 13. So negative 8 minus 5 is negative 13. Okay, integer man is going to go off the number line a little bit, but that's okay, we can still picture it. He's going to start at negative 8, and then he's going to go left 1, 2, 3, 4, 5. Those get squeezed in just a little bit, and he's also going to end at negative 13. Okay, next we'll look at if there's more than 2 numbers. We'll do the same thing we did before, where we just take it 2 numbers at a time. So we're going to start with negative 1 minus 5. So I have 1 negative, and then I'm going to take away 5 positives. So we'll add in 5 zero pairs. Okay, and then we're going to take away 5 of those positives. 1, 2, 3, 4, 5. So that portion of the problem would become negative 6. Okay, next I'll bring down minus negative 6. So negative 6 minus negative 6. That means we're going to start with 6 negatives. So that's actually what we already had, 6 negatives. Okay, and then this says take away 6 negatives. So since I already have negatives, I don't need to worry about zero pairs. I'm just going to take away all these negatives. 1, 2, 3, 4, 5, 6. And once I do that, there's nothing left over. So my answer to that would just be 0. Okay, showing this with integer man, he's going to start at negative 1. We're going to take away 5, so we're going to move to the left, 1, 2, 3, 4, 5. And then when we take away 6 negatives, that means he's going to jump to the right 6 places. 1, 2, 3, 4, 5, 6. and that has him ending at 0, just like the chips. All right, let's use an example where we've got algebra. Same example we saw with adding integers, video notes. This time we're just going to be subtracting. So just like we did before, we're going to substitute in everything that we know. So A is 5, B is -3, C is -2. Okay, now I need to be really careful about making sure I've got all the symbols. I'm going to bring down this subtraction sign, and then I'm going to bring down this subtraction sign. So 5 minus -3, and parentheses might help make that a little bit more clear, also for minus -2. Okay, 5 minus -3. Think about, we can start with 5 positives, take away 3 negatives, so add 3 0 pairs, and take away those 3 right there. So 5 minus -3 is going to be +8, and then we can bring down minus -2. And then for the second part, I'll show it with the number line just so you see both. Sketch out just the part we need. So 6, 7, 8, 9, 10. We would start at 8, and then since we're subtracting a negative, that means we're going to move to the right up to +10. So 8 minus -2 is +10. Okay, one more example kind of like that. We'll do the absolute value of C minus B. So just like we started with before, C equals -2. B equals -3. And then we'll bring down all those extra symbols. So we have absolute value, and then we have another subtraction. Okay, -2 minus -3. So if we decide to use integer chips, start with 2 negatives and take away 3 negatives. I'm almost there, but I need one more 0 pair in order to take away these 3 negatives. So when I do -2 minus -3, that part is going to be +1, and then the absolute value of +1 is still just 1, because 1 is 1 unit away from 0 on the number line. So final answer for the second example is just 1. Okay, that can start to get a little bit confusing when you've got all these negatives in there, especially things like 5 minus -3 minus -2. So there actually is a way where we can use our addition rules to help us with subtraction. So just as a quick reminder from before, when you add integers with the same sign, you add up the absolute values, keep the sign. When you add integers with different signs, you subtract the absolute values and use whatever you have more of, or whichever number has the larger absolute value. So all we need is a way to get from subtraction to addition. And there actually is a way that we can rewrite every single subtraction problem into an addition problem, and that'll help us out a ton in order to keep all of these rules straight. So here is the big way on how you can change all of your subtraction problems into addition problems. And you'll want to use this every single time you have a subtraction problem. It'll make things way easier so that you have fewer mistakes. Okay, the acronym that we're going to use is keep, add, opposite, or KAO. And that's going to just rewrite it. So here's our first example. We have -8 minus 10. You can draw basically 3 columns, and you're going to do that by putting the subtraction sign in the column. So if you have multiple negative signs, it would be whichever one is your subtraction. So I'm going to use keep, add, opposite, KAO. Okay, keep, we're going to keep -8 exactly like it is. We're not changing anything. For the subtraction part, we're going to change it into addition. And then in order to make sure the value is the same, we have to adjust that second number that we're subtracting, and we're going to use the opposite. So instead of using 10, the opposite of 10 is negative 10. So we have negative 8 minus 10 is the same exact value as negative 8 plus negative 10. And now since we have the same sign, negative 8 and negative 10, we can add 8 plus 10 to get 18, and then we're going to keep the negative. So negative 8 minus 10 is the same as negative 18. Okay, let's look at one more example, especially when you have multiple subtraction or negative signs lined up. This will make the problem a lot simpler. Okay, so column is going to go around the subtraction sign, which in this case is that first kind of negative sign that we see. So keep, add, opposite. Okay, negative 8 is going to stay negative 8. The subtraction symbol is going to change to addition, and then for negative 10, the opposite of that number is 10. So that first problem, negative 8 minus negative 10, has the same value as negative 8 plus 10. We're just rewriting it as an addition problem. Okay, this time we have different signs, negative 8 and positive 10. So we're going to subtract 10 minus 8. And then since we had more positive, there's 10 positives, which is more than 8 negatives, our final answer is going to stay positive. And in class, we have the investigation that we're doing, which will show this a little bit more as to why that works. But to keep this video shorter, we'll just use that as an example. All right, thank you for watching, and I hope this helps you with subtracting integers.